In problem number 11, we have in a league that has 5 teams, each team plays each of the other teams twice in a season. And what is the total number of games played during the season? Now, this is a variation of a problem that we call the handshake problem. And the handshake problem would be you have 5 teams, and each of the other teams each team plays each other team once in a season. And so you could represent this by 5 dots in the shape of a pentagon. And basically, team 1 plays team 2, team 1 plays team 3, team 1 plays team 4, team 1 plays team 5. And so that gives you 4 games. Then we come to team 2, but team 2 has already played team 1, so we don't need to count that again. But team 2 plays team 3, team 4, and team 5. And so we have 4 plus 3 games now. Then we go to team 3. Team 3 plays team 4 and team 5, since they've already played team 2 and team 1. And so we add 2 more games. And finally, since team 4 has already played team 3, team 2, and team 1, they just need to play team 5, and so we add 1 more to the total number of games. And what that comes out to be is 10. So it produces this series of numbers 4 plus 3 plus 2 plus 1. If you had, that's with 5 teams, so it starts out with 1 less and then it adds down to 1. If it were 10 teams, it would go 9 plus 8 plus 7 plus 6 plus 5, etc. You shouldn't confuse these with factorials, which multiply 4 times 3 times 2 times 1. And this is kind of what is often referred to as a Gaussian summation. And that would be x times x minus 1, or n rather, times n minus 1 over 2. We usually use n's when we're referring to natural numbers, as opposed to x, which would be a real number variable. So in this case, n is the number of teams that we're playing, so it's 5 times 4, which is 20, divided by 2 would give you 10. So that's a formula, if you can remember it, that will help you get the same result. But now this is only giving us for each team playing each other team once in a season. Now we could just do the same thing again and get 20, or you can count every one of the line segments in the diagram as 2 games instead of 1. So team 1 plays team 2 and team 2 plays team 1. So each endpoint of a line segment would refer to a game, as opposed to each line segment would refer to a game. And we would double count the endpoints. Actually, each vertex would be counted as many times as there are line segments terminating at that point. So, for example, at the top of the pentagon, there are 1, 2, 3, 4 line segments that terminate at T1, and so we would count that as 4 different games. Actually, each of the vertices, if you look at it in this way, each of the 5 vertices has 4 line segments that terminate there, and each of them would refer to 1 game. So basically what we have is n times n minus 1, which is going to be 5 times 4, which is 20, as opposed to 5 times 4 divided by 2, which would be 10. For those who see it, or who like to look at things in this way, you could look at these as permutations and combinations as well. The simpler problem, which is each team plays each other once, is a combination problem, whereas the more complex problem that play 2 games is a permutation problem. So if you take a second to follow that logic there for the combination problem, then the permutation problem would give a result of 20. So hopefully one of these many different ways of talking about this problem has there's something that you can relate to there and can understand and can use when you're solving this type of problem. Just make sure you look out for how many times the teams have to play each other.